Now that we've talked a little bit about what the ImageStreamGang example does using CompletableFutures, we're going to go ahead and show how to apply CompletableFutures to it in order to implement it. We'll start by talking about the factory methods and the completion stage methods. And then we'll go later and talk about the wrapper for the arbitrary arity method, all of. So we're going to focus on a hook method that's part of the StreamGang framework called processStream. And this is what has all the logic for doing asynchronous processing of the images. You can find it in ImageStream CompletableFuture1.java. There's another different implementation that's done a slightly different way, but this is the one we're going to look at here. The first thing we do is we call it the getInput method. That's one of the methods that comes out of the framework, and that returns the list of URLs the user has indicated they want to download. As you can see, this is going to combine the Java 8 sequential stream with CompletableFutures. So here's all the code to do that. If you were to go back and take a look at the corresponding parallel streams implementation, you would see it's a little bit shorter, and that's because it doesn't have to do the collecting the way that this works, and it also doesn't do this stuff. But other than that, it's kind of along the same lines. It's just that everything is done asynchronously. You'll also notice at the very, very end here, we have a call to join, and that's going to be used to wait for the results to finish. And that's because if we don't put a join here, this code will start to run, and then the program will just shut down, and it may not finish the computation by that point. So as I mentioned, with client code, you oftentimes need to use at least one join. But with server code, you can just let it run, and when it's finished, it's finished. This is the factory method that takes the list of URLs and turns them into a stream of URLs. So now we have a stream of URLs that we'd like to download. The next thing that we do is start checking if the images are already cached locally. And everything henceforth is very different from what we saw before. We'll come back and talk in more detail about what checkUrlCachedAsync actually does. It's pretty cool. That's going to end up creating something quite interesting. It's going to end up creating a stream of optional images. Or, I'm sorry, optional URLs. And I'll explain why we use optionals here in a second. And we then take the stream of optional URLs, and for anything in there that's non-empty, in other words, for all the ones that aren't cached, we're going to go ahead and download them asynchronously. And that's going to return an optional to a, it'll return a completable future, or stream of completable futures, to optionals to images. And I'll explain why we have optionals to images there as well. And the reason is because if something is going to be already cached, we don't want to bother downloading it again. So it's just going to be an empty optional. We now have a stream of completable futures to optionals to images that are in the process of being downloaded asynchronously. So we've got a stream of those things. And now what we want to do is we want to asynchronously apply filters to all these things. And the consequence will be to filter or transform the images that have been downloaded or have completed downloading. And then we're going to store those filtered and downloaded images onto the local file system, which could either be on your phone or your computer or whatever. And that will then return a stream of completable futures to optional images. And the final thing we're going to do is we're going to call collect. And as I mentioned before, that's going to go ahead and create a single future, completable future, to a stream of images that have now completed being downloaded and filtered and stored. So there'll be a single completable future that will come back from collect, and that will be a completable future to a stream, which is pretty funky if you think about it. The next thing we're going to do is we're then going to use the thenApply method. So keep in mind, everything up to this point, these are all stream operations, right? So we get a stream, we have a stream, we have a stream, we have a stream, and these are all streams of completable futures. And then the very last thing that happens is we get a single completable future back to a stream of results. And then we can use a completion stage method, thenApply, that will trigger this lambda expression after that single completable future completes. And when that single completable future completes, that indicates that all the other processing is done at long last. And it actually runs pretty fast because it's all asynchronous and parallel. And then we're going to take the stream of results and we're going to go ahead and get rid of anything that's empty. And then we're going to print out the size of what we got. We're going to go ahead and log the result. OK, so we'll talk more about that as we go through this stuff. And then the very final thing we'll do here is called join. And we need to do join because, as I mentioned before, otherwise the program would fall off the end before it was finished doing the processing. And you probably recall that in Java, if the main thread of control exits and there are no other non-daemon threads running, the program will shut down. And we wouldn't want that because we actually wanted to do something useful. So we end up calling join in the one and only place here in this whole sequence. So there's a lot of stuff going on here. I could have broken this up a little bit more granularly. I could have had all the part that was the stream part. I could have stored that into a completable future to a stream. And then I could have said, taken that thing and I could have applied this result. But I kind of chained them all together in a fluent style because that's pretty much the way people would write the code these days if you're using Java 8. All right, so now that you kind of see the big picture, let's dive down and look at each of the steps in more detail. So this is the part where we're going to check to see if an image is already cached locally. And of course, we're going to do this asynchronously. And we're going to be using this checkUrlCachedAsync behavior, which is a method reference that's implemented somewhere else in this class. So remember, this is going to call this method reference for every URL in the stream. So far, pretty straightforward. What this does is this map method will return a stream of completable futures to optional URLs. And what that means is if the URL is already cached, we get back an optional that's empty. If the URL that's we're requesting has not been cached, we get back a we get back an optional that has a URL in it. So you'll see later why we need to do this. We're needing to do this because we want to use streams, and we need them to process stuff, and we don't want to have to worry about nulls or values that don't have any, or elements in the stream that have no values. So we use optional to deal with that. The later operations in the stream simply ignore empty optional URLs. And we'll talk a bit more about optional. Optional, I mentioned optional much earlier in the course. Optional is a very cool Java 8 class that allows you to get rid of nulls in your programs. Because rather than having a null to indicate something's not there, you simply have an empty optional. So this is what's actually called the null object pattern. And it's an example of that. Quentin. Very good question. Why can't we just filter? Because there's no way to filter completable futures. That's the reason why. You can't write a filter expression that uses completable futures just because of the semantics of completable futures. You cannot use filter with it. It's maddeningly crazy. Were you to look at the implementation in this ImageStreamGang, you would see there was a second completable future implementation. And it does use some filter stuff, but it first gets rid of the completable futures part before it can do filter. So that's the reason. So that's why we end up having to use these these optionals, because we can't filter completable futures. So here is the code for checkUrlCachedAsync, and this is a really interesting helper method. You can see it takes a URL, and it's going to go ahead and use completable future and use the factory method of completable future to kind of kick off the whole processing chain asynchronously. So what this factory method does, completable future supplyAsync, you've seen this before, you're using it in your code for assignment number 4. What this does is has a lambda expression that registers this action. So this action will be registered to run in a worker thread in the background. And what this actually does is, well, let's see if I explain it. Yeah, I explain it in a second. So that's the action that's registered. And we have a little accessor method called getExecutor, which just returns the common fork join pool. So we're going to be putting this computation in the common fork join pool. And I'll talk about that later because we're going to have to use a managed blocker to make it work properly. Well, not in this case, but for other cases that may block. This particular piece of code does some interesting stuff. It takes the URL and it calls this method called URLCached. And we'll take a look at URLCached in a second. URLCached is basically the same implementation that we had with the parallel streams version. It just goes and sees if this URL already exists in the file system. If it exists, if it's cached, if URLCached returns true, then we return null as the value for the optional. So what that means is if you give an optional the value null using the of nullable factory method, that makes a, quote, empty optional. Otherwise, if the URL is not already cached, we're going to make the optional have the URL as its value. So the way to look at this is if you've already cached the URL, you get a null optional because it's empty. I should say an empty optional, not a null optional. Otherwise, we have a URL that we're going to be using to download. So that's what's going on here. And this computation is going to run in the background. And here's the URLCached method. As you can see, this just goes out and checks to see if the image has already been filtered before. That's the same, exactly the same code we had previously. OK, there are other ways to make image caches, but this one works good enough for our purposes. So that was essentially the starting point for this stream. We'll be asynchronously checking to see if an image is already cached. That's actually probably a pretty fast operation. Checking to see if something's already been cached won't take a whole lot of time, but to make the whole program fit together in some coherent way, we're going to end up using supplyAsync and CompletableFutures in order to get the ball rolling. And so it gets back a completable future, even though this completable future will probably finish very quickly. It's not going to block for any length of time. All right, let's now talk about completion stage methods. So far we used a factory method to get the computation initiated asynchronously with this call. And now we're going to call map. And we're going to use downloadImageAsync as the behavior to download the image if we need to. What the heck does that mean? Well, if it turns out that what we got back from one of our URLs was an empty optional, we're just going to skip over it in downloadImageAsync. So let's go ahead and sort of see how this is going to work. DownloadImageAsync downloads the image and stores it in memory asynchronously. And it will also return empty optionals if the URL it got was empty. So we just kind of cascade emptiness throughout the stream. And this will return a stream of completable futures to optional images. And the optional images will have a value if we actually have an image to download or an image being downloaded. Otherwise, if we already had cached the image the optional will be empty. OK, so here is downloadImageAsync. And this is pretty funky. So what we're getting here as a parameter is a completable future to an optional URL. And when the previous stage has determined asynchronously that there either is or is not a cached image, in other words, when the URL future completes, only after the URL future completes will this completion stage method get run, the thing that comes next. And this completion stage method is going to register this action, and this action will be executed when the future completes. Now, I told you before that this future will complete pretty quickly because it doesn't take too long to check whether an image has been cached already. But it may take a little bit of time. So this logic here will run when that future completes. And notice that we're calling this in the context of thenApplyAsync. So that means that this computation here will most likely run in yet a different thread in our common fork join pool, which is what getExecutor is returning here. Now, here's where things get really interesting. So take a look at this. What we'll get back when this future completes, we'll get an optional URL. So it's a optional that either has a value, which is a URL, or it has no value. So what we're going to do here is we're going to use the map method. So optional has a map method. And what this says is only run this method reference, this parameter, this behavior, which is called blocking download. You'll recognize that when we look at that in a second. Only run blocking download if this optional URL has a URL value associated with it. If it has no value because the URL was already cached, then don't run this behavior. So that's what map does. Map only does something if the optional is not empty. And so what it'll do in this case is it will asynchronously run blocking download if the URL is not empty. And blocking download, you may remember, is the method we talked about a while back that used the common fork join pool and the managed blocker mechanism in order to be able to download an image and do it in such a way, or perform a blocking computation, and do it in such a way where if there aren't enough threads, it'll go ahead and compensate by creating new threads. So this can dynamically create a new thread. In this particular case, we're using the common fork join pool, and so we need to use the managed blocker. If we had chosen to use a different type of pool, like we'd chosen to use a thread pool executor, like a fixed size thread pool or a cache thread pool, then we would not have been able to use the managed blocker mechanism, because managed blockers don't work on fixed size thread pools or any thread pool executor other than the fork join pool. So fork join pool can use managed blockers, but the other things don't. They don't work that way. So interestingly enough, the other implementation of the Completable Future ImageStreamGang app uses a fixed size thread pool, I believe. So if you want to look at that, you can see how that works. So the way to think about this stuff is when we determine, after we determine that an image, a URL has already been cached or not, after that has completed, then we're going to asynchronously download images that were not cached, and that will give back a completable future to an optional image. That's what's returned as the return value of this particular method. So we get back a completable future to an optional image, which could be empty if the URL had already been cached. Here's blocking download, just to remind you what it does. This transforms a URL into an image by downloading the image via the URL, and it uses the blocking task colon manage block method, which basically wraps the managed blocker interface. And as we talked about, that expands the common fork join pool automatically to handle blocking. And the last thing that gets returned here, as I mentioned, is a completable future to an optional image. OK, so what we're going to get back from all this, we'll get back a stream of completable futures to optional images. That's what comes back from map. So we'll have a stream of these completable futures. And then we're going to call flat map. Now remember, flat map is this funky intermediate operation that is able to give back more values in the output stream than were in the input stream. And in this particular case, that's very relevant because for each image that gets downloaded, we're going to apply multiple filters to transform that image. So let's say there are 2 or 3 of them. Let's say there are 3 filter transforms per downloaded image. So if we end up coming in here with n completable futures to downloading images, we'll leave with n times 3 elements in the output from flat map. So flat map can expand the number of elements in the stream, unlike map, where there's always just a one-to-one correspondence. This method, as we'll see, asynchronously filters images and stores them into files. And as before, it'll just ignore empty image values that would have percolated down because the images had already been cached earlier. Now, again, flat map sort of flattens things. In this case, we're just taking a stream and making a bigger stream. So let's go ahead and take a look at, and so flat map returns a stream of completable futures to optional images, and these things will be true. They will be present if things have actually been filtered and stored. Here is applyFiltersAsync. This is a more interesting and complex implementation of stuff. It's very cool. So what it does is it takes an image future, which is a completable future to an optional image. So this image filter will be triggered. It'll be ready to run when the image that was being downloaded completes being downloaded asynchronously. So what we're going to do here is we're going to go through all the filters. So let's say we have 3 filters that transform images. We're going to turn the array or the list of filters into a stream of filters. And then we're going to do the following. For each filter in the stream, we're going to wait until the future completes. So once the image is finished downloading, then for each of these filters, we're going to go ahead and call thenApplyAsync. So this processing is going to be applied only after the image is finished downloading, which of course makes sense. It doesn't make any sense to start processing an image or filtering an image that hasn't been downloaded or hasn't finished downloading yet, right? Here is the action that's remembered or registered with the CompletableFutures framework. And as we saw earlier, we have an executor. It's going to be the common fork join pool that we're going to use. And here is the logic that works with the image op. This is an optional image. So that's what's going to come out of the image future when it completes. We'll have an optional image. So what we're going to do here is we're going to say, if there is in fact an image that's associated with this optional, if that's the case, then we're going to go ahead and run this behavior. If there is no image, we just ignore things and we return an empty image again, an empty optional. So what we're going to do if there is in fact a non-null image, if there's something there, then we're going to call a method called makeFilterDecoratorWithImage, which returns a runnable, which we then run. So that'll run. It just starts it executing. And for each filter image combo, we're going to go ahead and filter and store that image in the file system. That's what this logic is doing right here. And that will then run in the common fork join pool. So keep in mind that this code is going to run when the image has finished downloading, and it will go ahead and asynchronously apply the filter, transform the image, and store the result into the file system. That's what this logic is doing here. But it only does that if there's a valid image. And then applyAsync returns a new completable future that will trigger when the image has been filtered and stored. So that when all that processing is done, then that completable future will be triggered. Now here's an interesting thing. Notice what's going on here. This is really funky. So we're taking the filters list, turning it into a stream, and then mapping each filter to do this transformation to the image. But notice how we don't have any terminal operation in this method. This method has no terminal operation. It just has a call to stream and map. So that means that what we're going to get back here is a stream of completable futures to images that are being stored, transformed and stored, or filtered and stored. And in fact, what you can see, the return value is a stream of completable futures to optional images. So that's really funky and wacky. So we're actually doing computation that won't even start to run until a terminal operation is ultimately reached. So the output of flat map will be essentially this stream of completable futures to all the asynchronously transforming and storing images. And that'll come back as a single stream. And as we'll see, this stream is going to be processed by collect, as we'll see in the next part of the lesson. Now, the other thing to keep in mind, this is completely crazy and funky. All the things I just described to you, I described these things to you as if they happened as I described them. But of course, none of this stuff happens until collect is hit, because this, of course, is a stream. And streams don't do any processing until a terminal operation is complete, or is encountered. So all these intermediate operations are not run until this operation runs. So this is and by the way, all the processing that takes place here is all asynchronous. So this is an extremely lazy program. So nothing starts doing anything until this is hit, and then all the wheels start turning in motion, and we'll end up with a stream of completable futures that will be collected together in a manner we'll talk about in a second. Okay, so that's the end of part 2. So that's kind of the workhorse part relating to the factory method that kind of kicks things off, and then the various intermediate operations like map and flat map that asynchronously process the results of earlier actions that themselves were asynchronous. So it's the classic completion stage pipeline.